Okay, so today we're going to talk about parallel and perpendicular lines. We're going to also write equations that from other equations that are either parallel to that equation or perpendicular to that equation and pass through a certain point on a graph. All right, so on the board I have a couple examples. I want to talk about some key features of parallel and perpendicular lines, which will help us out in our calculations. Over here I have parallel lines. I have a red line and a green line. As you can see, they're both parallel to each other. They're never going to cross. They increase at the same rate. And we actually have the equations on for both. We have y equals 2x plus 5 because the slope is 2 over here and it passes through the y-intercept at 5. This one down here, it's also y equals 2x, but it passes through at negative 3, so it passes through negative 3 on the y-axis. Now notice, what do you notice that's similar about them? They have the same slope. Parallel lines, since they increase at the same rate, we said that they have the same slope. All right, so these both have the same slope. So when we're going to write equations, we're going to find the slope of one equation and use it for the second equation because they should have the same slope. Now, perpendicular lines over here don't have the same slope. Matter of fact, they're going in opposite directions, perfectly opposite directions if you actually say. So we have a blue line going down that has a negative slope, so it's y equals negative 1/2. Because if you notice, for everyone it goes down. Where's a good point? It goes down 1, it goes over 2. So we have a negative slope of negative 1 over 2. The other one has a slope of 2. So it's going to go up 2 over 1. So the slopes are what we call opposite reciprocals. All right, these are called opposite reciprocals. All right, what does that mean? So that basically means if you take a fraction or a slope with rise over run, you're going to flip it upside down and then change the sign. So for example, in this example, on one slope I have negative 1/2. Okay? If the line is perpendicular to it, we're going to take this and flip it upside down. So 1 over 2, if I flip it upside down, now becomes 2 over 1. All right, that's called the reciprocal when we flip a fraction upside down. And then since that's negative, we keep it as a positive. I'm also going to do another example. Say I did positive 4, okay, as a slope. Now pertaining to the graph, but 4 is the same thing as 4 over 1. So if I flip it upside down, that now becomes 1 over 4. If this first one was a positive, then its perpendicular slope would be negative. Okay, so those are opposite reciprocals when it comes to perpendicular slopes. Parallel slopes are the same exact slope because they're increasing at the same rate. All right, let's move on. Let's do some problems. All right, this first problem says, write an equation of a line that is parallel to y equals 3x plus 5 and passes through point 1, 2. All right, so what we need, if it's parallel, let's use a different color. If it's parallel, it has to have the same slope. Well, we already have our slope in this one. Our slope right here is going to be 3. Remember, y equals mx plus b. The coefficient in front of the x is going to be our slope. Also over here, we have a point. We have an x value and a y value. So if I want to write an equation parallel to this, I can start off by saying y equals, I'm going to use the same slope as 3x. What do I put for plus b? I can calculate it. Okay, I have my slope. I have an x and a y value. So let's use slope-intercept to solve for b. So slope-intercept is y equals mx plus b. And I have all three of these points that can plug in, or inputs to plug in. And once I plug all these in, I can solve for b. Well, what's my y value? My y value is 2. So instead of y, I'm going to write 2. What's my slope? Well, we've already established the slope is 3. Let's put a 3 here for the m. The x is my x value of the point it has to go through, which is 1. So let's plug a 1 in. And we don't know what b is yet, so we're just going to put plus b. All right? So I have inputted all the information I have so far to solve for b, so I can finish out my equation over here. All right, so we still got to follow the order of operations. So I got to multiply first before I add or subtract anything. So the 2 is not going to change. 3 times 1 is 3 plus b. So now we're down to a one-step algebra problem. If we have a positive 3, the opposite of adding 3 would be to subtract. So I'm going to take the 3 away from there. Whatever I did to one side, I have to do to the other side. So I'll end up with, if I drop down to b is going to be equal to 2 minus 3 is negative 1. Now I know what my b value is. I already have the first part of it. So my answer is going to be y equals 3x, same slope, and my b is minus 1. So this equation right here is an equation of a line that is parallel to that line, but passes through that point. All right, get my point? All right, so let's do another one. All right, so in this one, we have an equation. We have a point at once we wanted to pass through. We want to make sure it's parallel. Well, that's not in slope-intercept form. All right, so we can't tell the slope. That's in standard form. Standard form has some other advantages, but one advantage it doesn't have is it doesn't directly tell us what the slope is. So we want to try to figure out the slope. So what we can do is convert this from standard form into slope-intercept form. All right, so slope-intercept form, what we want to do is we want to move the 2x over on the other side. All right, because slope-intercept form is y equals mx plus b. If you notice, the y is on the left all by itself. The x value is over on the right. All right? So let's move the 2x over. So if we want to get rid of it, we're going to subtract it here and subtract it from the other side. Just like we're trying to actually solve it, but we can't solve it because it has 2 different variables. All right, so that cancels out. What I have left is 8y equals. Now I can't take away 2x from 16. So I'm just going to write negative 2x because it's minus 2x, and that's a positive 16. All right, I'm almost to slope-intercept form. I get my y out in front. I got a number and an x. I got a constant there for my what's going to be my y-intercept. All right, so if I want to get the y all by itself, this says 8 times y. The opposite of multiplying by 8 would be to divide by 8. That allows me to cancel it out, and eventually I'll end up with just a y. But I can't just divide the y by 8. I have to divide everything by 8. So I'm going to divide this by 8 and 16 by 8. All right, so I still have my equal sign. So I have y all by itself. This will give me negative 2 over 8, which is the same thing as saying negative 1 over 4 for my slope. And this will be plus 2. All right, now, I have an equation. This equation is not parallel to that equation. It's the same line. All I've done so far is take this equation and convert it into slope-intercept form. Technically, they're the same equation. If I was to graph this and graph this, it would be the same line. However, oops, forgot to put my x in there. My students do that all the time. But they're watching like, oh, Mr. Wilson forgot to put an x in there. So what this tells me now is what my slope is. So just like we did in the last example, we need to find our slope because our new equation has to have the same slope if it's going to be parallel. All right, I have my x value, my y value. So let's plug what we have into our new equation. Well, my y value is 12. My slope is negative 1 over 4. And my x value is 4 plus b. So all I've done is I've inputted information into the running formula of slope-intercept form. Now I can solve for b and write my new equation. So nothing's going to happen with the 12. All right, 1/4 of 4, 1/4 times 4 is just 1. But a negative times a positive gives me a negative plus b. Now, since that's a negative, if I want to get rid of it, I have to add 1 to that side, but I also have to add 1 to this side. That cancels out, and yet it would be equals 13. So now that I have my y-intercept, and I know my slope, I can rewrite the equation. Y equals, there's my slope, negative 1 over 4, x, didn't forget the x this time, and then this will be a plus 13. So this will be the equation for a line that is parallel to that line and runs through that point. All right? All right, let's do one more. Let's do one with perpendicular. So instead of making an equation that's parallel to the other equation, we're going to make it perpendicular this time. All right, so the problem we have here is we want to write an equation for a line that's perpendicular to this equation, y equals negative 1/3 x plus 4, and passes through point 3, comma negative 4. All right, so we already have our slope. However, we're not going to use that slope. Remember, we want it to be perpendicular. So we have to use the opposite reciprocal. So instead of 1/3, the reciprocal is to flip it upside down. So instead of 1 over 3, we're going to make it our slope, we're going to make a 3. And instead of being a negative, the opposite would be to leave it as a positive. So my slope, my opposite reciprocal of negative 1 over 3, is simply just 3. Here I have my x and my y value. So now I can plug that into an equation and get an equation that is perpendicular to that equation. Let's do y equals mx plus b and plug our 3 values in. All right, so y is negative 4. Plug in negative 4 for y. My slope is 3. My x value is also 3. And then plus b, because we don't know b yet. We're trying to solve for b. All right, now we just solve. We got to multiply these first to follow the order of operations, or PEMDAS. So I'm going to get negative 4 equals 9. 3 times 3 is 9, plus b. Now, if I want to get rid of that 9, I'm going to subtract the 9 away from both sides. That cancels that out. And I get b equals, wow, I got like a 13 number again, although this is negative. Negative 4, subtract 9 more is negative 13. So my b value is going to be negative 13. I already know my slope. So let's rewrite the equation. Y equals a slope of 3, followed by an x, minus 13. There you go. This equation is perpendicular to that equation. All right, if you're just asked that if they're perpendicular or parallel, like on a test or something like that, all you need to do is look at the slope. If the slopes are opposite reciprocals, they're perpendicular. We go back one, if the slopes are exactly the same, negative 4 and negative 1/4, negative 1/4, even though they have different y-intercepts, that means they're parallel. All right. If you have any questions, please leave a comment down below. Give me a like. Subscribe even. I know. Subscribe even. That way you can be available for more math help from Mr. Wilson's Math Club.